Electrochemical cell is set up using iron 2 plus, an iron half cell, and a vanadium half cell. Okay, which of the following gives a correct effect on the E cell and a correct explanation? Means not just the effect on the E cell must be correct, the explanation must also be correct. Okay, so if you add KCN to this half cell, right, you add KCN to this half cell, essentially what it will form is this, and you must know that the Cn minus, right, the Cn minus is actually what I call a ligand, which you actually will learn under transition metal. It will bind to the Fe 2 plus to form FeCN6. All right, so this Cn is minus, there is 2 plus, so this is going to be 4 minus, right? So you're going to form this. So when you add Cn minus will bind to the Fe2 plus to form this. So I can just safely say that this value will decrease. Okay, but at first you need to know that the more positive one is the cathode and the more negative one is the anode. All right, so when you add Cn minus, the Cn minus will bind to the Fe2 plus, and the Fe2 plus concentration will definitely fall. So equilibrium wants to favor the backward reaction. Can you see that? Because according to LCP, and the E anode will actually decrease, right? The E anode will actually decrease. So when E anode decreases, right? When E anode decreases, E cell will increase. So which means this statement is actually correct. All right, this statement is also correct. So 1 is definitely correct. Okay, let's look at 2. Okay, adding water to the half cell. All right, adding water to the half cell, what happens to E cell? So over here you can see that when you add water, I want you to take note is you don't look at just on this one here. Okay, you don't look at this, because when you add water, in fact the concentration of this will fall, the concentration of this will fall, and the concentration of this will fall. So the concentration of all the aqueous ions will decrease, right? The concentration of all the aqueous ions will decrease. Okay, when that happens, by Le Chazelle's principle, it wants to increase the concentration of the aqueous ions. So you can see on this side, here, there are actually 3 ions, and this side there's only 1 ion. Okay, only 1 ion. So when all the concentration aqueous ions decreases, it wants to shift to the left. It wants to favor the backward reaction, okay, so that to favor the oxidation reaction, so that it can increase the number of aqueous ions. And when that happens, E cathode will actually decrease. So when E cathode decrease, in fact, E cell will actually decrease also. So this statement is actually correct, but actually this statement is wrong. Okay, so the explanation is because the concentration of the aqueous ions decreases. All right, so by LCP, all right, it wants to favor the production of more aqueous ions. All right, by LCP, so the position of equilibrium will favor the oxidation, will favor oxidation, means it will favor the backward reaction, okay, because that will produce more aqueous ions, and that will cause E cathode to decrease, and then E cell to actually also decrease. But the idea is not because of concentration of water increases, but because concentration of aqueous ion decreases. All right, okay, next one, increase the temperature of this half cell. So increasing the temperature will always cause the production of more aqueous ions. It's like trying to cause it to break the bonds, right, the metallic bonds, and you can get more aqueous ions. So increased temperature, all right, in fact I believe it will favor, yeah, it will cause the production of more Fe2 plus, and the E anode will definitely change. All right, so when they say no change, this is actually wrong. Okay, so the answer is actually A only. Okay.